Safer solvents and auxiliaries. The fifth principle is the use of auxiliary substances like solvents and separation agents, etc. should be made unnecessary whenever possible and when used innocuous. This means that we can use safer solvents, that is like water as a solvent, and we can substitute some harmful solvent with a less harmful solvents, and we can replace we can use some new solvents like ionic liquids and supercritical fluids. So this is the solvent selection table is shown here, and this is the preferred solvents like shown in green color, that is the water, acetone, ethanol, 2-propanol, 1-propanol, ethyl acetate, isopropyl acetate, methanol, methyl ethyl ketone, 1-butanol, and tertiary butanol. This can be considered as a preferred solvents. And then the undesirable solvents is like shown in the red color, that is pentane, hexane, pyridine, dioxin, etc., benzene. These solvents are very harmful to the atmosphere or to the will causes environmental pollution. It is harmful to all organisms. So we can use some solvents, usable solvents like cyclohexane, heptane, toluene instead of this undesirable solvents. And in this table also some solvents why they are considered as a red solvent. That is, a pentane is considered as a red solvent. Its flash point is -49. It is having very low flash point. So good alternative available. Because of this low flash point, it can capture fire very easily. So we can use another solvents instead of this. Solvents like heptane instead of pentane. So there is some solvents that can be replaced by other solvents, pentane with the heptane and hexane with the heptane, diisopropyl ether or diethyl ether with the tertiary butyl methyl ether, pyridine with the ET3N, that is triethyl pyridine, and also benzene with the toluene. Because of this, these red solvents can be replaced by some green solvents. And also we can use some supercritical fluids like supercritical carbon dioxide as a solvent. And the fifth principle is designed for energy efficiency. And according to this principle, the energy requirements should be recognized for their environmental and economic impacts and should be minimized. Synthetic methods should be conducted at ambient temperatures and pressures. That is energy. There is some energy loss in a chemical process as thermal energy, that is, and also cooling process due to cooling and distillation, microwave energy. There are some source of energy. And there are in a chemical, whenever we carry out some chemical process, we can use energy source as a thermal source or electric source, and distillation, photo, that means light, microwave is used as a source of energy. In the case of power plant, we can use coal, oil, natural gas as a source of energy. The energy use, according to these principles, we can use alternative energy source by a renewable energy source. And in this caprolactam process, this process can be carried out in presence of light, which is a renewable energy resource. And also microwaves are used, microwave radiation is used as an energy source. Its wavelength between 1 millimeter to 1 meter. More frequency fixed at 2.45 gigahertz, and more direct source of energy. Heating rate at 10 to the power of 0 per second is achievable. Possibility for overheating. Solvent-free conditions are possible. Interaction with the matter characterized by penetration depth. So we can use micro-radiation as an alternate source of energy. And the seventh principle is use of renewable feedstocks. A raw material or feedstock should be renewable rather than depleting whenever technically and economically practical. And thus we can use petroleum products, singly functionalized compounds and highly functionalized molecules. Can be used renewable feedstocks like biomaterials can be used, biofuels can be used instead of this non-renewable energy resources. These are some examples. There is polymers from renewable sources, polyhydroxy alkylolates. Alkylolates can be fermentation of glucose in presence of bacteria and propanoic acid. This product contains 5 to 20% polyhydroxy valerate. Let's also use polymers from renewable sources like polylactic acid. Raw materials from renewable sources, that is biofine process, paper mill sludge and agricultural residue, municipal and solid waste and waste paper. From this waste we can prepare levulinic acid. It's a green chemical approach for the synthesis of chemicals from waste. And this levulinic, we know that levulinic acid is a platform material for preparation of a lot of chemicals like butane, diol, THF, acrylic acid, succinic acid, MTHF, and also diphenolic acids, gamma, butyrolactone. And the eighth principle is reduce derivatives. Unnecessary derivatization, that is blocking group, protection of group, deprotection of group, temporary modification of physical or chemical process should be avoided whenever possible. We can make strategy, or we can develop methods for the synthesis of chemical synthesis by avoiding derivatization or unnecessary derivatization, or we can reduce derivatives. This can be done by either protecting groups. Protecting groups are used because there is no direct way to solve the problem without them. Two synthetic steps are added each time. One is used, overall yield and the atom economy will decrease. That is non-covalent derivatization. These are the methods that can be used for reducing derivatives.